Okay, so I think you wanted question 36, first question that you wanted. So let's try to solve this one. This is the question. It says a zero point 0.1 kilogram meat stick is supported at it is 40 centimeters mark by a string. So let's draw what it says here. It says you have a meat stick, and as you know, meat stick is a board that is 1 meters long. So that's 1 meters long. That's the whole length of the stick, 1 meters. Okay, and it is supported at it is 40 centimeters. As you know, meter stick will be 100 centimeters. In the middle, that would be 50 centimeters. So 40 centimeters will be around here. So there's a support around here, which is by a string. I'll call that Ft because strings usually have tensional forces. So there's a force that supports it, goes up. It attaches it to the ceiling. Okay, a 0.7 kilogram mass hangs vertically from 5 centimeters. So if this is the beginning of the board, 5 centimeters might be here, very close to one side. So that's a mass. That's mass here. And by the way, the board also was 0.1 kilogram. That was the board. And where is the center of mass of the board? It's exactly at the center. So the board has a mass. I'll call it M1, which is 0.1 kilogram. That's mass of the board, which will be exactly at the center of mass. And this will be M2, which the mass is 0.7 kilogram. So I have two masses now. Okay, and I know the distance, that was 5 centimeter. And I know the mass of the board, like from the beginning all the way to the center, that would be 0.5 meters, right? Because the whole board is 1 meter. Half of that would be half a meter. Okay, another mass is attached somewhere. It's somewhere on the board, another mass. So that means there's an M3, okay? It keeps the board both in rotational and translational equilibrium. It basically means you have F net equals to 0, that's translational equilibrium, and torque net also equals to 0, that's rotational equilibrium. If the force applied by the string attaching to the meter stick is this much. So Ft is given. This Ft that you see here, that was given, that's 19.6 Newton. Alright, then the question says, determine the following. First, find the mass of the unknown mass, right? The value of the unknown mass, which is M3. The unknown mass would be M3. I don't know where it is, and I don't know how much it is, but I gotta find it. Okay, let's see if we can do this one. Let's see how much M3 will be. Now, take a look here. How many forces do you have that is affecting this board? First, the mass of this board, which apply a force on the board. Because if you have mass, that means you have weight. And therefore, there's a force here. That's force 1. There's force 2 by the second mass. There's force 3 somewhere by the third mass, but I don't know it. So force 3 is unknown. And there's the fourth force that is from the tensional force that keeps it up, which balances all the other three first forces, right? So one force goes up, 3 forces go down. And how many of those I don't know? Only I don't know one of it, which is F3, right? Because you know Ft, that goes up, equal to all the other forces by F1, by F2, which goes down, and by F3, which also goes down, but I don't know where it is, and I don't know how much it is. So that would be translational equilibrium. All the forces that go up, which is Ft alone, equal to all the forces that go down, which is F1 plus F2 plus F3. Ft is how much is 19.6 equals to F1. How much is it? I don't know F1, but I know M. If you know M, that's okay, because 0.1, that's the mass, multiplied by gravitational acceleration will be force, because I know force means mg. Okay, plus F2, I know second mass, which is 0.7 times 9.81. That's the second force. And the third force will be M3, which I don't know how much it is. I have to find it. Multiplied by, again, gravitational acceleration, 9.81. Okay. So let's see what we get doing all the math. You could divide all the sides by the way, you can divide all the sides by 9.81. All those three 9.81s will cancel. That's one way to do it. But I have a feeling you will not like this. let's multiply everything. So this, you will get 0.981 plus, this should be then 0.7 multiplied by 9.81 will give you 6.867. That would be F2. And F3, I obviously cannot do the multiplication because M3 is unknown, right? I gotta find this one. And this is multiplied by 9.81. Okay. And that is 19.6 on this side. Alright, so I have those two numbers that I can add up. Let's add those two numbers. 0. So let me add those two and see what we get. 1 second. 6.867 plus 0.981. I will get 7.848 plus mass 3, which is unknown, multiplied by gravitational acceleration. And this all equals to 19.6. What do I do now? I'll have to take this quantity to the other side. So I'll subtract it. Right? It will be 19.6 subtracted by 7.848, and I'll get 11.75 equals to M3, and also multiplied by 9.81. And what do? I take 9.81 this time to the other side, becomes a division. So this is divided by 9.81, and the value that I will get will be 1.2 kilograms. That's M3. So that's how you solve it. Third mass was found this way. With what idea? With translational equilibrium. Why did I use translational equilibrium? Because I have three known. I know Ft, I know F1, I know F2. I just did not know the mass from F3. I had everything else. Then I did my math and found F3. Easily done. Second question, it says, where is D3? This mass that we had here, where is it exactly? For this one, because I need distance, I cannot use translational equilibrium. I'll have to use rotational equilibrium, because rotational equilibrium contains distance in it. And rotational equilibrium, same thing. The torque that goes up, which is torque T, torque tension by the string, which goes up, equals to all the other torques. Torque 1 plus torque 2 plus torque 3. Torque 1 is Ft multiplied by distance of the string. F1 will torque 1 will be F1 d1. That's from the board. And torque 2 will be F2 d2. That's from the second mass. And torque 3 will be F3 d3. Which one I don't know? D3. This is what I want to find. Okay. Ft, how much was it? 19.6 was given. Where is the distance of the string? Distance of the string was, if you remember, was I forgot to write it here. It's 40 centimeters, right? That was the distance of the string. 40 centimeters means 0.4, 0.40 or 4, no difference, meters. Okay, so I know the left side. Everything from the left side I know. First force equal to 0.981. That was F1. 0.981 multiplied by first distance. Well, that was from the board, if you remember, from mass 1, first distance, which the distance was exactly in the middle, so 0.5. Okay, so D1 will be 0.5 plus, let's do this. And F2 was how much? 6.867. 6.867 multiplied by D2. Where was the distance of D2, of the second mass? The second one from M2, the distance was only 5 centimeters. 5 centimeters means 0.005. That's what it means. Plus F3, how much was it? F3, we didn't multiply F3 here, but I know M3 now, which M3 is 1.2. I found it, that is M3. multiplied by gravitational acceleration, 9.81. And then what should I find? I should find d3. d3, which is your unknown. Now I can leave the following calculation for you. I'm sure you can do it. Multiply those two, multiply those two, multiply those two. Then those two must be added. Add them, right? And then take them to the other side. And then those two should be multiplied. And then you take them to the other side. Once this is taken to the other side, becomes subtraction. Once this is taken to the other side, because there's a multiplication here, it becomes a division. So this one becomes a subtraction, this one becomes a division. I'm sure you can do that.